so pre-calculus 20, we're talking about section 6.3. We're talking about adding and subtracting rational expressions. So 6.1 was exploring rational expressions, simplifying them, noting restrictions. 6.2 was multiplying and dividing rational expressions. With 6.3, we're adding and subtracting them, which actually requires us to do one extra thing in order to add and subtract. It's not the same as multiplying and dividing. Okay? So we're adding and subtracting rational expressions. All right, most of you are in Physical Science 20 right now, or physics, and this should look familiar to you. This is a little bit, the variables are different, but we're talking about here the lens equation, right, which we're studying this very day in physical science. Sorry, so right here. All right, so this should look somewhat familiar. U is the distance of the object, so that's dO, and V is the distance of the image. So if you remember from Physical Science 20, those of you that are in there, 1 over di plus 1 over dou equals 1 over f. And if we were actually needing to write an expression for the addition of these, then we would have to do that a certain way. So let's just, let me zoom in there. Let me copy this into our notes. You can write this down. 1 over f equals 1 over u plus 1 over v. Okay? So if we actually wanted to come up with an expression for f, let's say, then what we'd have to do is we'd have to combine these terms over here. All right, so if we're not sure how to do that, let's try and think of what we would do if we had 1 over 7 plus 1 over 5. If we had to do something like that, who remembers how we add fractions? What do you have to have before you can add two fractions together? What's the first step? Who remembers? Just shout it out. Common denominator. Very good. Common denominator. So the denominator is obviously the bottom of each fraction. And we want to get these to equivalent fractions that have the exact same denominator. So what's the lowest common multiple between 7 and 5? Well, 7, 14, 21, 28. Okay, it goes on. Where does it end? 35 is the common denominator. So if we make these both over 35, and what do you have to multiply 7 by? Well, times 5. So we're going to multiply this one by 5. So that's 5. This one has to be multiplied by 7. So we'll multiply the top by 7. So that's going to be 7. So this is actually 12 over 35. We can add the top numbers while keeping the bottom numbers the same. Okay? So over here, this leads us to how are we going to deal with rational expressions. Same principle holds true. We have to get a common denominator. Okay? So you might look at this and you say, well, how do we do that? Well, what's common between u and v? What's a common multiple? Well, if we have two variables, the easiest common multiple to get is just when you multiply them together. So that's what we're going to do. We're going to write this as 1 over f equals. And each of these fractions we're going to write as over u times v. All right? So you ask yourself, what do I have to multiply u by to get uv? You have to multiply by v, right? So we have v over uv. Over here, this is times u. So you have u over uv. Okay? Everybody with me there so far? Common denominator. Now, we can go like this. V plus u over u times v. We can combine those two terms. And this is the essence of what we're going to be doing in this section. That is how we add rational expressions. So if we want to find an expression for f, then I can take the reciprocal of both sides, and it's u times v over v plus u. Okay, if we wanted to do that. So that's a connection to science, and we haven't done this in science. We haven't broken it down like this before in science. But anyways, so that's how we would do that. Okay. So going back to the lesson here. Oh, that's pretty zoomed in. So they just kind of talk about that. What do you do with fractions, and then what do you do here? So let's go over some examples here. So in the textbook it says, in the case where the denominators are the same, you simply add or subtract the numerators. So if they're the same already, you simply add or subtract the tops, whatever you're asked to do there. if the denominators are different, you have to get a common denominator. And it is helpful to factor first. Instead of just multiplying them straight out, it's a good idea to factor first because you may not have to multiply by such large expressions. So let's actually just focus in on this one a little bit. Okay. So this example right here, you want to copy that down, and you can have this in your notes so you can see what's going on. So if I wanted to actually subtract this, and this is the cursor, don't worry about this thing by the 4. So what we want to do is we want to get a common denominator. They're definitely different, but it's a good idea to factor first. So this actually looks like this: 10 over 3 times x minus 4 minus 3 over x minus 4. So we need to have a common denominator, and this is another way that I like to think about it. When you've got everything factored, everything needs to have what the other rationals have in the denominator. So everybody needs to have a 3 as a factor. Well, this one does not have a 3 as a factor, but we can put one there. If I do that, I have to multiply the top by 3 as well. Okay? So both terms need to have a 3 as a factor. Both terms need to have an x minus 4, and they already do. So this simplifies now to 10 minus 9 over 3 times x minus 4. See that? Common denominator now. We can simply subtract the tops. So that is 1 over 3 times x minus 4. Okay, restrictions. Again, if we're asked for restrictions, you have to realize that those are always a possibility. If you're asked to solve something, you have to consider the restrictions that x cannot be. I won't worry too much about the restrictions here, but x obviously can't be equal to positive 4, right? Okay, so that looks like it should be your simplified answer there. Any questions or observations there? All right. Okay. So let's just take a look at this one. It's in your textbook as well. We won't write it down, but if we had something like this, that looks pretty complicated, right? The common denominator there is actually not that difficult to find if you factor both denominators. So x squared minus 9 is actually x minus 3 times x plus 3. And this one right here is a perfect square trinomial, x minus 3 times x minus 3. So you look at this and you say, well, both of them have an x minus 3, but this one has 2 x minus 3s. So this one needs another x minus 3. This one does not have an x plus 3, so this one needs an x plus 3. So let's just go ahead and do this one as our next example. Okay, and I know this might seem like kind of boring stuff. Maybe it is, but it's really important. Okay, it's really important to get this straight. So this one on the right has 2 factors of x minus 3, so this one needs 2 as well. You see that? They both need to be the same. And so I'm going to multiply the top by x minus 3 and the bottom by x minus 3. On the right side, this now, okay, every term that we add, so that's these 2 terms, needs to have all of these factors. This one doesn't have an x plus 3, so we need to put an x plus 3 down there. What we do to the bottom, we have to do to the top, so that we're not changing the actual fraction, the rational. So our common denominator now is the combination of these 3 factors. And then up top here, I have to multiply this out, right? So that's going to be 3x minus 9 when you multiply this out. Plus 4x plus 12. That's what this is. So these steps are important. The quicker you get at this, the more you'll be able to do in your head. But again, I would strongly suggest it takes you literally seconds to write this out. Really, just write it out, and then you'll make fewer mistakes. So 3x plus 4x is 7x. Negative 9 plus positive 12. That's the same as 12 minus 9. That would be 3. And then over here you have all of these factors. This is also an important note. You do not have to multiply all these factors together. That'll take you 5 minutes. That you do not have to do. Okay? Simplified form, remember, for a rational is factored. So that's good. So don't multiply these out. Okay? You do not have to multiply those out. Let me just write that down here. Do not have to multiply these factors out. All right? That's important. Okay? You should factor the top if you can, but it's kind of already done. Okay, do you guys have any questions for me so far? Okay, I'm going to get you to do one question on your own to see if you can do it. It's not going to be the easiest question I can find, but it's going to be one that will... where did I see that? There we go. So why don't you do this question right now, and your turn. Take a few moments to do that. And this will tell you and I, mostly you, if you can do this or not. Okay? All right. So write a simplified expression for the subtraction of these two rationals. Go ahead. All right, so here's the solution. Let me walk you through what we're seeing here.
Did you see your mistake?
All right. So first thing you got to do is factor the denominators. Okay, you have to factor because you have to see what you have. Don't do this. Oh, x squared minus x squared. Let's just get rid of that. Oh yeah, x minus, no. Can't do that. It's only the tops that you can combine, and you can only combine them when you have a common denominator. So, do you see how I factored x squared plus x minus 6 into these two? This was factored into this right here. So on the left, this guy over here did not have an x plus 1 in the denominator as a factor. And over here, this guy did not have an x minus 2 as a factor. And so you multiply top and bottom by the factors that each of them are missing in the denominator. So what you want to do after that is to be very careful of this. You cannot now go like this. Oh, x minus 2 and x minus 2. Great. You can't be doing this because we have this minus sign. You have to expand this out and then gather like terms. Expand this out, right here, these two, and gather like terms. So x squared minus x squared, those are gone. We have a negative 4x. That's a positive 4x. You also have a negative 1 minus a positive 4. That's negative 1 minus 4 is negative 5. Note the restrictions. So the restrictions come from those factors in the denominator. Okay. So how many of you got that before I showed you? Okay. Okay, some. If you are, depending on how much you're struggling with this question, that should tell you how you're doing so far on this lesson. If you did not get past the first step, put your hand up and I'll come talk to you. If you got all the way through, you're good. If you got halfway through, well, we might have to do some more examples. All right, I will do one more example just for the benefit of the class here. So let's do the one that's the one I see here. So one more example. Copy this out, and again, see if you can do this before I even get it done, if you want to go ahead and prove yourself. Okay, so let's do something like this. Now, if you want to note restrictions right away, go ahead. X cannot equal negative 5 over here and negative 1. That's awesome. What we do have to do is look at the denominators. They are not the same in this example, so we have to make them the same. So this one over here needs an x plus 5. So multiply top and bottom, x plus 5. To the whole top, right? This one over here needs an x plus 1. So let's multiply an x plus 1 up there. So if you want to, you can write a common denominator now of x plus 5 times x plus 1. This one right here, that multiplication, looks like this. 2x squared minus x plus 2x. Okay, I'll write it all out. Minus x plus 2x minus 1. That's what this is. Minus, and I always really encourage you to use brackets after a minus sign, because if you don't use brackets, you might forget that the negative sign applies to all of the terms. So use brackets right here especially. And then this is x squared, right, plus 5x minus 4x minus 20. So then we want to simplify the top. So let's gather some like terms. I see a 2x squared minus 1x squared. So that's simply x squared on the top. This is a negative x plus 2x. That's plus x. Okay, so we've got x minus 5x. That's negative 4x. And then minus a negative 4x. If that's too much to do in your head, you can jot that down on the side or whatever. You can combine these in the first step too if you want. But I think that should be 0x, right? Let me just see. 5 minus 4 is 1. That's 1 minus 1. Okay, so those x's are gone. And we have a negative 1 minus a negative 20. So that's negative 1 plus 20. Negative 1 plus 20. X squared plus 19. That looks about right? Okay, this can't be factored. These can't be factored. There, I think there should be your answer. So let me know if that's what you got. All right. And again, a good way to check this would really just to be kind of make sure that you've done things correctly and double check your multiplication and stuff like that. Okay? So make sure the top and the bottom, the denominator on the bottom and the numerator on top is factored. Divide out common factors, show your restrictions. That's a complete answer. Okay? Any questions on that?